the objectives of Chapter 2 is the writing of nuclear equations. These can be used to express nuclear decay as well as other nuclear reactions. When we write nuclear equations, we always include the mass numbers, which are found on the upper left-hand side of the symbol, and atomic numbers, which are on the lower left-hand side of the symbol. The sum of the mass numbers and the sum of the atomic numbers must be equal on both sides of the arrow. This example expresses the alpha emission of the isotope uranium-238. On the left side of the arrow is the symbol for uranium-238 with a mass number of 238 and an atomic number of 92, which we could find on the periodic table. On the right-hand side of the arrow is the symbol for the alpha particle or helium nucleus, as well as the isotope-produced thorium-234. There's a mass number of 234 and an atomic number of 90, which again can be found on the periodic table. When we sum the mass numbers on the right-hand side of 234 plus 4, that is equal to the mass number on the left-hand side of the arrow, 238. Likewise, when we sum the atomic numbers of 90 and 2, that is equal to the atomic number of 92 on the left-hand side of the arrow. As a reminder, the alpha particle has a mass number of 4 and an atomic number of 2. The beta particle has a mass number of 0 and an atomic number of -1. Gamma radiation has a mass number and atomic number of 0, and a positron has a mass number of 0 and an atomic number of +1. You will be expected to use these symbols correctly. For example, to write an alpha decay or emission equation, an alpha particle is produced, so that will always be written on the right-hand side. Likewise, in beta emission, a beta particle is always produced, so that will be written on the right-hand side of the arrow. If gamma radiation is produced, that will be written on the right-hand side of the arrow, and if a positron is emitted, then the positron symbol will be written on the right-hand side of the arrow. In the next video, we'll go through some examples.